Alright, this is Concept B for Unit 13 on redox and electrochemistry. We're going to just focus on reviewing how to assign oxidation numbers. As you saw in our first concept in class, that we're going to be working with elements gaining and losing electrons and the effect of oxidation number when that occurs. So here we're just going to simply practice rules that we've learned earlier in the year. So oxidation numbers, this is the charge that an element is or appears to have when certain rules are applied that we're going to go through. Oxidation numbers can be positive, negative, or zero. So the first rule is any uncombined elements, this means they're not bonded to any other element, will have an oxidation number of 0. So examples would be solid aluminum by itself, chlorine gas by itself. These are not combined with any other element. So this rule falls under, for single elements or diatomic elements. You're going to assign them a charge of 0. Oxidation numbers of simple ions is their charge. So chlorine ion in this case is going to be -1, aluminum will be +3. Group 1 metals have a +1 and group 2 metals have a +2 charge. And you can find this on the periodic tables. So this is an easy one to kind of remember because you can always look it up, but it is helpful to know it right offhand. Fluorine is going to be -1 in compounds, and this is always going to be true for any of the ones we're going to be doing this year. There's no exceptions to this. The other halogens, so the other elements in group 17, are also -1 when they are the most electronegative element in the compound. Most of the ones that we're going to do, when the halogen is written second as the negative ion, they're going to take on that -1 charge. The only exception will be if you see a halogen out in front with a positive charge, then you got to be a little bit careful and then do some math related to it. Alright, moving on. Hydrogen is going to be +1 in compounds, with the exception of when it's combined with a group 1 or group 2 metal. This is called a metal halide. This is when hydrogen is going to take on a -1 charge, and that just has to do with electronegativities, and we'll discuss a little bit further in class as well. But most of the time, hydrogen is going to be +1. Oxygen is going to be -2 in most compounds, and that's why when you look on the periodic table, oxygen only has a -2 listed as its most common oxidation number. Now there are two big exceptions that you need to memorize. The first one is for peroxides, and in general this has an N2O2 general formula. So hydrogen peroxide H2O2, or you could have sodium hydroxide, which is Na2O2. In both cases, oxygen is a -1 charge. Another exception for oxygen is when it is combined with fluorine. Because of fluorine's very high electronegativity, oxygen takes on a positive oxidation state, and this is where it's going to be +1. So any oxygen fluoride compounds, oxygen is +1, but most of the ones we're going to do, you can assign oxygen -2. And then in general, compounds with the sum of their oxidation numbers always is going to be set to equal to 0, and any polyatomic ions, which you know from table E, the sum of their oxidation numbers will always be equal to the charge on the ion. So just make sure we're going to be doing a lot of just little math steps to make sure that these two rules are being covered throughout our examples. So here I picked out a specific element, but we're going to have to use the other elements to solve for it. So for this first one, I'm going to plug in and set this compound equal to 0 because it's neutral, and then I'm going to follow the rules for hydrogen and oxygen. Hydrogen, I'm following the rule for it being +1. Oxygen, I'm following the rule for it being -2. And again, this is review, so you might remember this. Here we're going to be multiplying down and dividing up. So each oxygen is -2, and we have 3 of them. So that means the sum of all the oxygens is -6. Each hydrogen is +1, but we have 2 of them. So +1 times 2 is going to give me +2. Okay? So these are just the sum of all the oxidation numbers for hydrogen and for oxygen. So now that we have this set equal to 0, the missing value here, or solving for x, is that sulfur, the sum of the sulfurs have to be +4. Now I only have 1. So +4 divided by the 1 means each sulfur is +4. And that's it. Okay, moving on to iron chloride. Here we're going to again set it equal to 0. Each chlorine is -1, so I'm following the rule for the halogens when they're the most electronegative element. Each chlorine is -1, so -1 times the 3 that are present, so again I'm multiplying down, means that I have a -3 overall charge for just the chlorines. Now to balance out the chlorines, each iron, or the total of the irons, have to be +3. Because I only have 1 of them, I'm going to divide up by 1, so +1 divided by 1 gives me +3. And so now I know iron has a +3 charge. Right, here we have our first polyatomic ion, or phosphate ion. I'm simply just putting this into brackets because the sum of these is -3. A lot of students see the charge on table E and just automatically assign it to oxygen. Make sure it stays separate. This is just giving you the sum of the PO4 oxidation numbers. So following the rule for oxygen, we are assigning it -2. -2 times the 4 oxygen present gives me -8. Okay, in order to balance this, x minus 8 equaling -3, our phosphorus has to be +5. I only have one phosphorus, so +5 divided by 1 means each phosphorus in this polyatomic ion is +5. Alright, so see if you can pause, try out the next 3 on your own, and then check your answers. Going through this, here we have another compound, setting it equal to 0, hydrogen being +1, oxygen being -2. Getting the sum of their oxidation numbers, -2 times the 3 that are there, -6, and then 1 hydrogen is contributing a +1 to the compound. In order to balance out the compound and have it equal to 0, we then have +5 for nitrogen. We happen to just have 1 here, so +5 divided by 1 means each nitrogen is +5. Alright, for our polyatomic ion, again, I'm just putting this in brackets because, again, this -2 is not being assigned to oxygen. This is the charge of the entire polyatomic ion. So I'm just putting the brackets on to keep it separate. So here, the sum of all of the oxidation numbers is going to be -2. Following my rules up above in your notes, each oxygen is -2. -2 times 7 means all the oxygens contribute -14 in this compound, which means that if I want the sum to be equal to -2, all the chromiums have to be +12. And then here, be very careful, +12 is for the sum of the chromium atoms. Here we're going to divide by the 2 that are present, meaning that each chromium is +6. So this would be the oxidation number for chromium, not the sum of them below. And then finally, we have an exception here. Fluorine has to be -1. Remember I said there's no exceptions that you need to be aware of for fluorine. So -1 times 2 gives you -2, which means the oxygen has to be +2. So this is one of those exceptions for oxygens where it does not take on a -2 charge due to fluorine's electronegativity value. Alright, well that's it. You're going to be practicing this a lot in class tomorrow, and some of you I will not be there for, so just make sure that you go back through some of your notes and especially look at those rules and examples you can use tomorrow in class. There's no quiz or summary that you need to do for this unit, so you are all set.